So this is another way to solve percents. Some people prefer to use equations, while some people like to use proportions. And so what happens is when we use proportions, it's the idea of a proportion. Remember, proportion is always a fraction equaling a fraction. All right. So what I usually do is I like to, give you like a basic what it looks like. All right. So a percent is always the idea of the percent goes on top, and a percent's always over 100. Now I know from most of you from last year, you know that really well. So that's something very easy. On this side, what happens is a percent is going to end up being the part over the whole. All right. What part are we talking about, and what's the whole we're talking about? 100% represents the whole. A percent's going to represent what part of the whole. May it be 100% and be all of it, or 0% and be none of it. All right. So we're going to look at the idea of changing it to a proportion using this. So part, whole, percent, 100. Now, here's the part that gets a little tricky, is that when we use the idea of is and of here, it gets a little more confusing, because what happens is, how do I know what the whole is? All right. So what's usually going to happen is our whole is usually going to be the word of. All right. In a class of 250 people, so that word of is usually going to be our total. What of? All right. And then what happens is our part can sometimes go with the word is, but I don't really want to say that very often. I'd rather just know what the whole is. Now, I'm not going to tell you that every time you see of, it's going to mean whole, or like we said before, multiplication. But I want to make sure that we're looking sometimes at the context of whatever the whole is. In a bag of Skittles, there's 250 pieces of candy, and it's you got to think sometimes what the whole is going to be. All right, so it's not always going to jump out at you. So let's come down here, and if you've done the other notes already, you'll see that that's the exact same questions. So we're just going to set up a proportion this time. Now, the very easy one is the 35%. We're just going to say 35 over 100. Very easy. Now, the tough part now is the 125. Is it going to be on top or bottom? Is it the part or the whole? So what is 35% of 125? Well, that of, again, gives us a hint that it's going to be the whole. All right? So we're going to try to put that in the bottom and kind of use that as going to be what we're looking at, which means this is our unknown. We don't know what this is. So now what we can do is, remember we said before in class, this times this is equal to this times this. All right? So I can use that information now and say, well, 100x is 100x. All right? That's easy. All right, and I can do this diagonal now. 125 times 35. I'm going to go off screen just a little bit. So 125 times 35. All right, so this times this needs to equal this times this. So 100x just can come down. This we can just multiply really quick. 125 times 35. You can do it by hand, or you can do it with a calculator. And that equals 4,375. All right, now again, it's an equation, so you can almost get that idea again of this. How do I get that 100 away? How do I get x by itself? Divide by 100. Divide by 100. And x will equal 43.75. And that's what we're looking for there. All right, now if we look real quick, we can come back to that other equation. You'll see later on, or if you've already seen, it's the exact same thing we got over here. All right, so it doesn't matter if you do an equation or if you do the proportion, it's still going to have the same idea, being 43.75. All right, so let's try B again. All right, so 180 is what percent of 2,000? So I start with the proportion. All right, what percent? I don't have a percent here, so I automatically know that's my variable, x over 100. I don't know what the percent is. That's what I'm looking for. So now I have to figure out what's on top, what's on bottom, and it makes a huge difference in this problem. If you put 180 on top and you put 2,000 on top, you get two completely different answers. But you can also see how that could work towards a multiple choice question. You can see where some of those answers are going to come from, and that's that whole trick, where they're going to come from. All right, so what we're going to look at now is what's the of. There's our of 2,000, so that means it's the bottom. The 180 is going to go on top. All right, you can see it goes with the is, but like I said, it doesn't always go there. So 180 is what percent of 2,000, of being our total. So we can use that idea of this. This times this equals this times that. So the diagonals have to equal each other. That's true with any fractions that are equal to each other. That's true with every proportion. The diagonals have to be equal to each other for it to be equal. So I can say 2,000 times x equal to 180 times 100. So 2,000x is equal to 180 times 100, which is going to be 18,000. I divide by 200 on both sides. 2,000, I'm sorry, on both sides, and I get x equals 9%. Right? And just because I know it's a what percent. So that's my answer is 9%. And I went off screen a little bit there. So now the idea is what we're trying to see is what's the good and bad about both of them. Let's take a couple seconds and look at both for a second. B, notice we get a percent. The other side, all right, remember we got a 0.09 and we had to convert it over to a percent after that. So there's a slight difference there of having a decimal and having to convert it over. Whereas this one, it's already out of 100, so your answer is your answer. All right? So try this one real quick, see how you do, and we'll go from there. So try it real quick, press pause, and we'll go back. All right, so again, we can look at this real quick and say, hey, 26.3 over 100 equals of what? So that of being our hint again, that's our total, and then 312.6 on top. All right, so I can show the shortcut. Remember the shortcut we said in class? This times this divided by this will give us x. All right, so I can say 312.6 times 100 divided by 26.3 will give us our answer. So I can say 3126 times 100 divided by 26.3. I put it in the calculator wrong. 312.6 times 100 divided by 26.3, and that gives us 1188 again, as we got in the other notes. 0.6, and that's going to be our answer. All right.